In this video, we will discuss the tertiary treatment of sewage water. Earlier, we discussed the primary sewage water treatment as well as the secondary sewage water treatment methods. Under primary method treatment, we discussed how the solid particles are removed by using various screens, and in secondary wastewater treatment, we discussed how the aerobic process as well as the anaerobic process helpful in removing the suspended solid particles. But in the tertiary treatment, we are going to concentrate on how to remove the fine colloidal particles from the sewage water. Only then that sewage water, after all the treatment, it will be useful for agriculture purpose or even for drinking purpose. So the removal of fine colloidal particles in the sewage water by adding some chemical coagulants is called as tertiary treatment. We add some chemical coagulant which will causes the precipitation of fine colloidal particles in the sewage water. An example for such chemical coagulants that includes alum, ferric chloride, ferric sulfate and so on. And these coagulants react with colloidal particles and form a gelatinous materials which is called as flake. And this method is useful for removing heavy metals also. After all the treatment, primary, secondary and tertiary, the sewage water will be useful for agriculture purpose as well as for drinking. So under tertiary treatment, the first method we follow is oxidation pond. What are oxidation ponds? In the earlier secondary treatment method, we discussed aerated pond or aerated oxidation sludge, and then anaerobic digester and all. But here we follow oxidation pond. That means we make ready with a shallow pond whose depth would be 2 to 4 feet. And the other name for oxidation pond that includes sterilization ponds, stabilization ponds, redox ponds, maturation ponds and sewage lagoons. So here is the diagrammatic representation of the oxidation pond. Here you have something called inlet pipe. The sewage water from various industries after the primary and the secondary treatment are introduced into the oxidation pond. You can have one inlet or even you can have multiple pipes or multiple sites for the entry of sewage water. So once it comes into the oxidation pond, because of the wind action on the surface of the water that causes the aeration of sewage water in the oxidation pond, and which will allow the diffusion of oxygen on the surface. So at some few feet at the surface, the oxygen level will be quite higher, and that will allow the growth of aerobic microorganisms. So aerobic microorganisms that oxidize the organic compounds or the suspended colloidal particles in the sewage. And there is another thing at the bottom of the sludge, where the oxygen level is little low, which is the conducive environment for the growth of anaerobic microorganisms. Anaerobic microorganisms are also involved in the oxidation of organic materials that's present in the sewage. And the clarified and the treated effluents are collected back, and this will have a low BOD. If the pond is similar in size, we can go for another oxidation pond. The sewage water first treated with first oxidation pond. After that, it will be collected and sent it to the second oxidation pond for further purification. Finally, the purified sewage water is discharged into a river or used for irrigation purpose. Regarding the effluents, the treated sewage water is collected and discharged into a river. What happened to the solid fraction? The sludge that deposited at the bottom of the oxidation pond, that has to be removed quite often. The effectiveness of the oxidation pond in removing the sewage or the fine colloidal particle, that depends on how often we remove the waste or the solid fraction or the sludge that get deposited at the bottom of the oxidation pond. It is frequently removed from the pond, And you can also grow, in order to speed up the process of oxidation of organic materials, you can also grow algae or other lower organisms. One very good example is Eichhornia crassipus, which can consume more sewage for its growth. Next, we will discuss the advantages of oxidation pond. So, as you have seen the methodology of oxidation pond, you can say that they are the easy method of treating sewage water, and it is a cost-effective method. That means low cost for its maintenance, and doesn't need any skill supervisions, and maximum potential to reduce BOD of sewage water, and it reduces nearly 99% of the bacteria from the sewage water. And you can use this oxidation pond for also for the growth of algal biomass, say for example spirulina, and which can be harvested from the pond and used as a source of protein in diet. And the second methodology that is followed in tertiary treatment is ion exchange method, because in the sewage water you will have organic materials as well as ionic materials, minerals and so on. So how will we remove this calcium, magnesium, other anions, cations, such compounds? That is removed with the help of ion exchange method. It is a chemical method for the purification of wastewater after secondary treatment. Here we will use two tanks. One is anion exchange, first one is consists of anion exchange resin, and the second one is containing cation exchange resin. So first let us talk about anion exchange resin. First you must know the difference between the anion and cation. Anion, which is the negatively charged molecular species, and cation is the positively charged, the overall net charge of the compound, based on which we classify anions and cations. So, in order to remove the anions, we use some specialized material that is called the zeolite. So, zeolite, which is a natural compound containing aluminium, silica and soda. When you use this zeolite in the sewage water, the minerals, the calcium, magnesium, they have a strong tendency to get attracted to the zeolite and get accumulated in the zeolite. And these elements are washed out when salt water is passed through the zeolite. And the zeolite is reusable after washing with neutral water. So you can think of zeolite like some skeletal material which consists of a lot of pores and which is made of aluminium, soda, silica and so on. So when you use this in the sewage water, the ion exchange method, this will absorb all the calcium, magnesium. So calcium and magnesium get accumulated in the zeolite. After that you remove it, wash it with salt water, and then when you use salt water, all the magnesium, all the elements that get attached to the zeolite are washed out, and then you can again wash the zeolite with the neutral water. So thereby you can use the zeolite again and again for in the anion exchange resin. What are the advantages of zeolite? So zeolite, when you use zeolite, there is no formation of sludge. So in the case of oxidation pond or the activated sludge process or the packed bed reactant, whatever, you will get some sort of sludge. But in zeolite, you won't get sludge formation at all. And it is easily operated without skilled personnel and no problem of deposition of calcium and magnesium. And hardness is reduced to 0. Aeration of water increases the strength of zeolite. And the last one is cation exchange resin. When the waste water is passed through this resin, hydrogen atoms of the resin is exchanged with metallic cations. Say for example, clinoptilolite or carbonaceous material is used as a resin column. Phosphate and ammonium ions are removed from the water. After accumulation of these ions, the resin column is reusable after treatment with diluted sulfuric acid. So with that we have completed. So as overall, ion exchange method is a highly effective method that makes high quality drinking water from wastewater. So overall we discussed secondary wastewater treatment and tertiary wastewater treatment. In secondary wastewater treatment, we use something called activated sludge process, which make use of the activated carbon powder, which is the inert material that used to attach with the suspended solid particles, or carrier advanced sludge process. And we use different reactors, an anaerobic process that includes packed bed reactors in which microbiomass is used, biofilms are used, biofilters are also used, anaerobic filters, and then filter units, example contact beds, intermittent sand filters, and then trickling filters we discussed. Under tertiary treatment, we discussed two methods. One is oxidation pond, the other one is ion exchange method. Hope this is useful for you.